Vanakkam one and all. We will discuss exercise 5.1 8th problem. Here they have given a function f of x and the function's points of discontinuity. They are asking for the points of discontinuity. The function is mod x divided by x when x is not equal to 0, and if x is equal to 0, functional value will be 0. So which means we'll just consider about the domain of the function. So if you assume if it is a real line, this side goes up to plus infinity, here it is minus infinity, and we have 0, and for all real numbers x not equal to 0, they have defined the function as mod x by x. And here also for all real numbers x not equal to 1, not equal to 0, has the function as mod x by x. But if x equal to 0, the functional value is 0. So which means the function is defined for all real numbers. Okay, the domain of the function is the domain of the function is our entire real number. Now if the real number, if x is a real number which is greater than 0, if x is greater than 0, according to the definition of mod x will be x, if x is greater than 0. So if x is greater than 0, mod x by x will be x by x, which is nothing but 1. So when the values of x are positive, we will get x by x, which is nothing but 1. Okay, so if x value is negative, less than 0, in that case mod x will be minus x. So mod x by x will be minus x by x, which is minus 1. When the input values are negative, we will get minus 1 as a functional value. Okay, so for all real numbers we have to consider about the real numbers which are positive, functional value is 1, and the numbers which are negative, the functional value is minus 1. But we have to worry about the point 0. So we can say for all real numbers positive, the function will carry the functional value as 1. So we can say which is constant, right? So we can say the function is continuous for all real numbers which are positive, and for all negative numbers also the function will say minus 1 as its functional value. So the function will be continuous for all numbers which are negative. So we can say the function is continuous on real number, remove 0. So in this real line the function is continuous. So 0 is the point where we have to worry about the continuity, because when the value is 0, when the input is 0, we are getting functional value as 0. So let's check the continuity. So when we have 0, we have to worry about we have to consider about its limits. So this is right hand neighborhood and this is left hand neighborhood of 0. So functional value, when the value of x is 0, the function will be 0, and we'll consider about the left hand limit. So limit x tends to 0 minus, which means approaching 0 from left hand neighborhood. So in that case, what about the function in x less than 0, which means in the neighborhood we will have negative elements. So we'll get the function as minus 1. So this term is independent of this 0, we will get minus 1. And right hand neighborhood, limit x tends to 0 plus, which is right hand neighborhood where the elements are positive, so the function value will be 1. Here the left hand limit is not equal to right hand limit. So we can say the function is discontinuous at 0, and in the remaining parts of real numbers the function is continuous. So we will say f of x has discontinuity at x equal to 0, and in all the remaining parts the function will be continuous. To say function is continuous, we have to say left hand limit and right hand limit equal, and that value is equal to the functional value. Here the left and right hand limits itself are not equal, so we don't have to worry about. Okay, here itself we can conclude the function has discontinuity at x equal to 0. We will do the next problem now. Now this is problem number 9. Here again they are asking for the points of discontinuity of function f, where f of f is defined by f of x is equal to x divided by mod x if x is less than 0, and if x is greater than or equal to 0 they have given the functional value as -1. So we'll consider a real line. So in a real line, this is positive infinity, it goes up to minus infinity, we have 0, 1, 2, 3 and so on, -1, -2. Okay, so now here in this, if x is less than 0, so less than 0, so suppose assume up to this, so whenever the values of x is less than 0, we have the function as x divided by mod x, and when the value of x is equal to 0 and more than that, the function will be -1. So when the values of x is less than 0 means we will have 0 to minus infinity, and for this one can be written as 0 up to infinity. So union of these two will give us the domain of the function. Okay, domain, which is nothing but entire real line. So domain of the function is real line. Now we will consider about the continuity. So for all x greater than or equal to 0, for all x greater than 0, for all x greater than 0, f of x will be -1. Yes, which is a constant function. Constant function. So constant function is a continuous one. Okay, so therefore f of x is continuous for all x greater than 0, and for all x less than 0, what will happen? X divided by mod x, according to the definition, mod x will be minus x if x is less than 0, so we will get -1. So again, for all x less than 0, f of x will be -1, which is a constant again. So f of x is continuous for all x less than 0. Now for all positive numbers it is continuous, as well for all negative numbers. Now we have to check the continuity at 0. Okay, so we can, okay, at x equal to 0, what about the functional value? When f of 0, the function will be -1, the output will be -1. Now we'll consider the left hand limit. Limit extends to 0 minus, approaching 0 from left hand neighborhood. So what about the function we have in the left hand neighborhood? We have x by mod x, so that one can be -1, that is -1. Okay, and we'll have -1. So this term is independent of x, so we'll have -1 only. Now we'll consider about the right hand limit. Limit h tends to 0 from right hand neighborhood. So again here the function is -1, which is constant. So again it is independent of x, so we'll have -1. So here left hand limit exists and right hand limit exists. The existed value limits are equal and that limit is equal to the functional value, that is f of 0. So as f of x tends to 0, we are getting -1, which is equal to the functional value. So we can say the function is continuous on entire real line. So the function is continuous on R. So there is no point of discontinuity. There is no point of discontinuity. So we will discuss. Okay.